scientific notation is really easy, but there's just one little catch that gets a little confusing. It's just like this teeny tiny little thing we have to do. But our first two examples, you're going to be like, wow, this is boringly easy. Okay? 2 times 10 to the 5th times 3 times 10 to the 4th. Well, just imagine this is like 2.0 or 3.0, right? So it's still one digit. Okay, so put your pencils down, look, listen, learn. Pencils down. Everybody looking up at the board? Nick, close your iPad. I don't want any distractions.
Well, I do have my iPad closed.
Okay, well, from here I can't tell. It just looks like it's open from where I'm sitting. Can you put it down flat on the desk so that I know for sure? That could be our signal. Thank you so much. Okay, here we go. Coco, you ready?
Yeah, I'm just copying.
Okay. Lily's ready. Eli's almost ready.
Yeah.
I want you to go sit down so you don't miss the magic.
What is this do?
I don't even think that's mine. You can just throw it away. Unless you want to keep it for whatever reason. Okay. Thanks. I hope you feel better. See you Monday. Okay, ready for the magic?
Yeah.
I'm going to take the first two things in front of the first parts of scientific notation. I'm going to multiply them and I'm going to get 6. And then I'm going to take the 10 to the 5th times 10 to the 4th. And because that means I add the exponents, I'm going to get a 9. Ta-da! Multiplying scientific notation. That's it. It's boringly easy. Yes.
That was crazy.
So I kind of told him that after you said had ready for the magic, I just imagined kind of in Harry Potter from Harry Potter the kind of sequence, the guy saying after all the math one, he just like was like just this is just like magic.
Yep. Sometimes math is magical. Okay, let's do another example. You can write that down. Pick up your pencils. You can write that down now. Thank you for waiting. Okay. 4 times 10 to the negative 6 times 2 times 10 to the 12th.
Wait, you said negative 12?
It's negative 6 and positive 12. Did I say negative 12?
Yeah.
I meant positive 12. I'm sorry. Thank you.
I just heard 12. I might prefer 12.
Okay, so same thing. I'm going to multiply the 4 and the 2. And then I'm going to add the negative 6 and the positive 12. So what is negative 6 plus 12? 6. So you're going to have to pay attention to those integers. Remember, those are going to haunt you for a very long time. Got to know those integer rules.
Yay, being haunted.
Mm-hmm.
Haunted mansion.
So I saw something on You guys know I like the TikTok, and I saw this thing and I was like, oh man, that's so smart, but it never occurred to me, and I don't think you can't use it for multiplication and division, but for positives and negatives. You guys ready for this?
Sure.
This is totally sidetracked. Okay, so if I have like -4 plus 3, right? I draw negative, 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 positive, positive, positive. Cross out the ones that have pairs, and what am I left with?
Negative.
-1. Isn't that brilliant?
Wait.
Is it
So,
all that?
yeah,
It
no,
makes
no,
Right?
sense.
Wait, I have a question.
You can do
Awesome.
it for any of them.
I have a question on that. So, depending on how many of the remaining thing, that's how many of that negative
Yep.
positive there is.
Yeah, so look
that
here.
one is
So I would have 1, 2, 3, 4, 5, 6, and then 1, 2, 3. So cross out the ones that have partners, and what am I left
positive
with?
3.
+3. What? Now the only thing is that you can get some pretty large numbers and you have lots of positives and negatives, but what about, try this one. This is so exciting. And the girl who was doing it, it's like this, she has her own TikTok and all she does is like sit there eating food and like doing math, and she doesn't say a word. But like, she teaches like a 30-second little, right? So if I have -2 plus -9, negative, negative. Do any of them have a positive partner?
No.
No. So I would just count up how many negatives I have,
Negative 11.
and I'd have 11 of them. Right? That's so exciting.
That's great.
That's pretty
You
cool.
said food. You got me into that.
Oh man, she just sat there. I think she was eating like macaroni and cheese or something.
Lucky.
Okay. All right, last example. This is where it's going to get a little bit confusing, but I think you guys can handle it. Three times 10 to the 8th power times 5 times 10 to the -5th power. Okay. So I'm going to do the exact same process. I'm going to get 3 times 5, and I get 15. 10 to the 8th times 10 to the -5th is going to give me 10 to the
So
10 to the 3rd. Let me know when you see it. What's happening here? Because I'm not done yet. What is it?
The first number is 2 digits.
The first number is 2 digits, and we can't do that. Okay? So because we have double digit,
Double hockey sticks.
we can't leave our answer like that. Okay? So what that means, if you look up here at the board, so I can do 15 times 10 to the 3rd power. I can still use the process. This just isn't written in proper scientific notation. So if I did this, this would be 15. My decimal's here. 1, 2, 3. I get 15,000 as my answer, right? So this is still equivalent, but again, it comes back to this not being in proper scientific notation. So I have to fix this. So what I'm going to do is I'm going to take this decimal and move it here. So if I have 1.5 and I want to make it into 15,000, I have to go one extra loop.
So you would just
So I make that a 4, right? So because now I have an extra loop to travel, because I moved the decimal here, I now have to do times 10 to the 4th to balance it out.
makes a lot
Right?
of sense.
If I make it travel one more space, I have to show that so the person who's converting it back to standard form knows it's 15,000, not 1,500.
So we were right exactly. That's the shower work.
I'm going to show you exactly what you would do. Okay? So you would draw an arrow and you would put 1.5 times 10 to the 4th. That was just me trying to show you visually what's happening. You don't have to write all of that. But we're going to add ourselves a little note. since I added a loop, right, I made it harder for the decimal to travel. I had to increase the exponent by 1. Because 15 to the times 10 to the third is the same as 1.5 times 10 to the fourth. But now we have it written in proper scientific notation. Okay. We gotta do the whole thing. We can't just stop halfway at this. Any questions? Okay, Tuesday we'll continue with division. Go ahead and put this in the back of your semester 1 of your binder. Thank you guys for being good listeners.